Hi friends, today we are going to discuss about ordinary least squares, which is otherwise called OLS.
Tell me, what is OLS?
Ordinary least squares is a type of linear least squares method for estimating the unknown parameters in a linear regression model.
Ordinary least squares, or linear least squares, estimates the parameters in a regression model by minimizing the sum of the squared residuals. This method draws a line through the data points that minimizes the sum of the squared differences between the observed values and the corresponding fitted values.
You are right. Moreover, ordinary least squares regression is a statistical method of analysis that estimates the relationship between one or more independent variables and a dependent variable. The method estimates the relationship by minimizing the sum of the squares in the difference between the observed and predicted values of the dependent variable configured as a straight line. In this entry, OLS regression will be discussed in the context of a bivariate model, that is, a model in which there is only one independent variable which is called x, predicting a dependent variable is called y. However, the logic of OLS regression is easily extended to the multivariate model in which there are two or more independent variables.
Now we are going to discuss about the key assumptions of OLS.
Assumption 1. The linear regression model is linear in parameters. That is, when the dependent variable y is a linear function of independent variables x and the error term, the regression is linear in parameters and not necessarily linear in x.
Assumption 2. There is a random sampling of observations, which means that the sample taken for the linear regression model must be drawn randomly from the population. The number of observations taken in the sample for making the linear regression model should be greater than the number of parameters to be estimated. Independent variables should impact dependent variables. The error terms are random. This makes the dependent variable random.
Assumption 3. The conditional mean should be 0. That is, the expected value of the mean of the error terms of OLS regression should be 0 given the values of independent variables.
Assumption 4. There is no multicollinearity or perfect collinearity. Multicollinearity occurs when independent variables in a regression model are correlated. This correlation is a problem because independent variables should be independent. If the degree of correlation between variables is high enough, it can cause problems when you fit the model and interpret the results. In OLS there is no multicollinearity, which means that there is perfect collinearity.
Assumption 5. Spherical errors or specification error. That is, there is homoscedasticity and no autocorrelation. First I will explain what is homoscedasticity. IT describes a situation in which the error term is the same across all values of the independent variables. Heteroskedasticity is present when the size of the error term differs across values of an independent variable. The impact of violating the assumption of homoscedasticity is a matter of degree, increasing as heteroskedasticity increases. In other words, this assumption means that the variance around the regression line is the same for all values of the predictor variable x. The plot shows a violation of this assumption. For the lower values on the x-axis, the points are all very near the regression line. For the higher values on the x-axis, there is much more variability around the regression line. The second term, autocorrelation of a random process, describes the correlation between values of the process at different points in time, as a function of the two times or of the time difference. The most common form of autocorrelation is first-order serial correlation, which can either be positive or negative. Positive serial correlation is where positive error in one period carries over into a positive error for the following period. Negative serial correlation is where negative error in one period carries over into a negative error for the following period. Let us conclude according to this OLS assumption, the error terms in the regression should all have the same variance.
The last assumption 6 explain, error terms should be normally distributed. This assumption states that the errors are normally distributed, conditional upon the independent variables. This OLS assumption is not required for the validity of OLS method. However, it becomes important when one needs to define some additional finite sample properties. Note that only the error terms need to be normally distributed. The dependent variable y need not be normally distributed.
Let us conclude the concept of OLS. Thanks for watching.
Thank you.